Hi there. My name is Mark. I'm sort of the principal author, I guess, of StrangeIoC. And I'm going to be talking today about Strange, about dependency injection and inversion of control. And my talk today is called The Good, the Bad, and the Strange, Kicking the Singleton Habit. So I'm going to jump into the first slide here. So what I want to get at today, and what I really want you to be able to walk away with, is an understanding of why a particular very common habit in coding generally, but it's definitely a particular issue in Unity coding, you need to know why it's a problem and understanding it's a problem, what you can do to solve it. So the core of this problem is a basic issue to do with object-oriented code. We all understand the idea of objects, that you are going to code the things in your application or in your game. And the idea of creating these objects is to separate your code, to compartmentalize it according to its use. And that's great, but inevitably there are points in which those various separate pieces need to know about each other. Two objects need to know that they've hit each other and therefore something happens, or you press a button which causes something to happen. And the connections between the classes lead all those beautiful separate objects to start becoming intertwined with each other. So you're moving away from spaghetti by creating objects, but you're moving back towards spaghetti by connecting those objects. And you get the problem that we call dependency, or sometimes interdependency. And that's a problem because what it means is that your code starts becoming inflexible. It starts breaking in places that are hard to identify. It doesn't become, or it becomes less easy to change and update. And so we want to avoid this problem. This is a foundational issue in coding, and one that we're told, somewhat wrongly, that object-oriented code solves for us. It does solve it with a sort of asterisk, and that asterisk is really what this talk is all going to be about. So let's move on, and let's look at the common solution that you'll find all across the Unity world. As I say, this is not just Unity, but very common in Unity, is to use what's called singletons and static methods. So what is a singleton? If you're not familiar with this term, a singleton is a class that has been written such that only one of them will ever exist during the lifetime of an application. So a typical example, as I'm showing here, would be the model representing the player in a one-player game. So what you might say is you might create a static method called getInstance, and you call that on the player model. So you'd say player model.getInstance dot do something. Something might be level up or add points or jump or hit or die or any of those sorts of things. And because we've decided that this is a one-player game, we know we only ever have one player, and therefore we can say, okay, go to the player model, get the instance, and then do something on that instance. And you've theoretically solved a problem that was, how do I get access to the player model from any random location in my application? Well, that's great, except, and by the way, that's easy to conceptualize, they're easy to write, and that's fine, except that you start creating problems that you're going to have to pay for. This is what we call technical debt. It's a problem that you've created, and the longer your application lives, the more things you build into it, the bigger these problems become, and this is a debt you're accumulating, and eventually you have to pay off that debt. So why are we accumulating debt? Well, for one thing, every time I have to access a player model, I'm creating a specific concrete dependency somewhere else in the app. So if I have a button that when it's clicked says player model.getInstance.add points or level up, or birth if I want to create a new instance because the last one died. Anytime I communicate with the player model, I now have a concrete dependency, and the more of those I have, the more complicated and interconnected my application starts becoming. So what ends up happening is you make little changes here and there, and after a while, all of your app depends on all of the rest of your app, which means things become hard to test because you can't break them apart easily. It means that the whole application requires all of the rest of the application to work correctly, or else it can be really hard to figure out where things are breaking or how things are going wrong. It also means that your code starts to become what we call rigid. Rigid code is code that is hard to change, because as you make changes in one part of the app, you start breaking parts in the other part of the app. It also becomes brittle, and that's actually, they are related terms. Rigid is the inability to change. Brittle is the ability to break easily. So when things start going wrong, they often start going wrong in strange, hard to fathom, and catastrophic ways. So although the singleton allows you to get at stuff easily, it starts building up all this technical debt and all this problems and all this rigidity that you will pay for the longer your code lives, the more stuff you are building up. So we tend to look really quite negatively at the singleton, even though it's a well-recognized design pattern, but everything I'm describing also points out that it comes with a very well-recognized anti-pattern. So there is a better solution. It's not perfect, it's not quite where we're headed, but here's something that you may have heard of, and this is better: the factory and the interface. So an interface, if you're not familiar with the term, is simply an expression of the inputs and outputs of a class. So this is an example. I have iPlayer here. So iPlayer could be the player model, but it could also be, say, something called another player or super player or some other term that we've come up with. And that's cool. So this is a little better, and I know that an iPlayer has methods like add score, level up, birth, die, whatever terms we want to use, whatever instances, or I'm sorry, not instances, whatever methods and properties we want to define can be put into the iPlayer interface. So now you've freed up your code from the concrete dependency on player model. But what you do in order to access that interface typically is you use a factory. And a factory is a class that delivers you instances. And this is a little better because now the factory, you can go to the factory and say, hey, give me an instance of the class that I need. And now you're acting on the interface instead of acting on the singleton. So it's an improvement. We're writing the interface. We're lessening our independency. It's a little better for testing because now you can substitute in, say, mock players for the real one when you're doing testing. So that's cool. But the problem is you're actually kind of just swapping one problem for another. Now you need to know about, instead of knowing about the player, you need to know about the player factory. And you may have to do less with the factory, but you still have to know about it, so you're still creating that dependency. And therefore, you have to, you might need a factory for your factory, or you need some other way to get your client class to know about the factory, and you start running into structural concerns, the code. You can make this work. I mean, this isn't the worst solution. It's better than the singleton, but it's still not perfect. A much better solution, and the one I'm recommending to you today, is called inversion of control. Now, inversion of control, classes become much easier to write. They're very flexible. They're highly customizable. They are clean and testable. And you basically are going to learn today about how you can take what were concrete dependencies and turn them into abstract dependencies. And an abstract dependency, by its nature, is much more, it meets all these terms much better. So, having said this, I was, come up with this term, inversion of control. Well, what are we in fact inverting? The conventional programming model, as we did, say, with the either with the factory or with the singleton, was to say, give me a player model, to use the player model example. So player model.getInstance dot do a thing. So give me a player model and I'll do something with the player model. The factory was much the same. It says, hey, factory, give me a player model, or give me an iPlayer, and I'll do something with it. That's the conventional approach. The inversion that we're talking about is to have something else tell the client class that it needs a thing. So we call this, in this system, we call that the injector. And all your class has to do, and I'll show you an example of this in a minute, all your class has to do is say, hey, I have an abstract dependency on something that satisfies this iPlayer interface. And then the injector comes along, looks at the class, says, oh, look, it needs an iPlayer. I have a mapping for an iPlayer, and it hands it whatever the appropriate mapping is. That mapping could be player model, but it could be something else, and that's where this gets really, really clever and powerful. Our class doesn't have to know where the iPlayer is coming from. It doesn't know whether there's one. Is it a singleton? Are there many of them? It doesn't even know that it's a player model versus another player versus super player versus any other type of thing. Anything that satisfies iPlayer is sufficient so long as it satisfies that interface. So it becomes a much more flexible approach. Okay, so we're inverting what we're asking for. So you're going, like, what the hell is he talking about? I don't understand. I'm lost already. Okay, so let me walk back a little, and we'll do this again, and I'll try and show you. So in the singleton approach, the player model, in your typical singleton approach, we would say, get instance. And get instance means if no instance exists, create it, and if it and if it does exist, give me the one you created previously. That way you only ever get one. So this is how you would write this if you were looking at it from a client class. I have some class that needs a player model. So why is this a problem? Well, a player model has to be written as a singleton. And now your class has to know that it's a singleton. Well, why does your class care that it's a singleton? What is the advantage of knowing that it's a singleton? There's really none. All it wants to know is there's somebody out there I need to talk to. Talk to it. The fact that it's a singleton really doesn't enter into it from the point of view of the other class. And because the player model has been written as a singleton, it can never not be a singleton without you refactoring it. And everything else that knows about it, because it has to call getInstance, also knows it's a singleton. So imagine now for a moment that you had a single-player game, and you decided to make it a multiplayer game. You can probably imagine the scope of that refactor, just the enormity of making a change like that. And it's not as if inversion of control will make that trivial, but the order of magnitude of the problem will be mitigated by an enormous amount because you won't have all these concrete dependencies lying around. So instead of saying player model get instance, we're going to do this injection thing, and if you make a change, if you decide that it's no longer a singleton, then you won't need to change code everywhere that touches player model. You'll only need to make changes to player model, and maybe a few points in between where you decide which player model is being handed to a class. So because the other thing that's really important here is because this says player model, it can't ever be, say, player 2. It can't be another player model. Let's say let's take another example just for a moment. Is imagine that what we were talking about instead of the player model was a Facebook service. All right, so you want to contact Facebook and log in and do various things and post and all this stuff. Well, that's great until your boss walks in one day and says, can we add Google Plus to that? Or Twitter or Pinterest? Well, now you have to go back every place you've touched Facebook and that Facebook service, and you're going to say, oh, okay, well, if it's Facebook, go to Facebook, or if it's Google Plus, you have all these if-else statements for Twitter and Pinterest, or maybe you may have to do a number of things. You may even want to be able to handle multiple social services at once. Well, guess what? Posting to a wall is actually pretty much the same, regardless of whether it's Twitter, Facebook, or Google Plus. There's differences that specifically affect Facebook or specifically affect Google Plus. But in general, most other classes outside that service don't need to know those differences. And from an object-oriented point of view, they shouldn't know anything. They should be completely ignorant of this fact. So I press a button that's going to post to a wall. If I have to go everywhere and say, well, either it's going to be Facebook or it's going to be Google or it's going to be Twitter, well, that you can imagine how complicated that gets. So instead, when we inject, it'll just be a social service. And whether that social service handles Facebook or Google Plus or Twitter or maybe a combination of all of them is going to be of no interest to that other piece of class. The other piece of class. Well, you know what I mean. It's going to be of no interest to that other piece of code. So that was the singleton example. Now let's look at the inversion of control approach to the same problem. Instead of saying, I want a player model, and I want to get an instance and know that it's a singleton and know that it's the player model, all I need is something called iPlayer, or it's got the interface to iPlayer. Very importantly, we give it this inject tag. That's a signal, it's a meta tag, and it's a signal to the injector that we're going to inject this in. So it's basically just saying, okay, I have a dependency on something that satisfies iPlayer. So we have a basic setter here. And then once it's injected, I can call any method I want on that and know that I'm good because it got injected. It got injected at instantiation. Everything's cool. Was the injected class a singleton? Who cares? Your class certainly doesn't care. Was it the player model, the other player model, the Zaphod player model, or to use the Facebook, Google? This could be here, social service. And the social service could be Facebook, Google, Plus, Twitter, whatever, or something that handles all of them simultaneously. Your class doesn't care. Why should your class need to know which social service that you're going to? You want to replace the thing that you've injected with some other different thing? Go right ahead. Your class couldn't care less. That's the whole magic of this. Because the injection is abstract, because we're using an interface, because it's abstract, and because it doesn't need to know where this dependency comes from, you can throw anything in there. And that's great for testing because it means you can mock up objects for testing purposes. It's great for flexibility because you can change things up really fast and really easily. It makes everything much, much easier. Your whole world will be a cleaner, easier place when you understand why this is so useful. All right, so what we are doing, so I've been using the term inversion of control, but what we're actually doing when I talk about injection and an injector is a principle called dependency injection. And I think by now you probably even understand what that means. Classes indicate a dependency. The injector satisfies that dependency by injecting it. So I have something which satisfies an interface. We'll go, in this case, I'm going to call it iThing, and we're going to bind it to the cool thing. So, iPlayer to player model, or iSocial service to Facebook service. And note here, importantly, I then map it to a singleton. So, this is important. I didn't write a singleton. Once you start using injection this way, you will never write a singleton again. Instead of writing a singleton, I map it to a singleton. And then, if I should change, as we were talking about before, from a single-player game to a multiplayer game, I can say that it's going to be to singleton, or I could remove this, and by removing it, it becomes a true factory. It will give me new instances every time I ask for it. So I am able to determine whether or not I want it to be a singleton as a mapping rather than as a way that either the class that is providing the singleton or the class that consumes it, the client class, has to care about. And what this means is, again, your code becomes much less focused on how it's being used and more focused on what it actually does. So that's the binding. We bind the interface to the concrete class, to singleton if we like, and then the consuming class, the client, just marks an injection and says, here's an interface that I need satisfied. And when that class gets instantiated, we scan it, we identify the injections, we look for the bindings, and if the bindings exist, we satisfy them. If the binding doesn't exist, we'll throw an error. So we'll help you identify that you've done something wrong, that you have a dependency that isn't being satisfied. So that's what's really cool about this. Right now, we're binding this thing as the cool thing, and we're saying it's a singleton. If we decided it wasn't a singleton anymore, we could just change the actual mapping instead of doing anything in the client class itself. All right. So here's a very important quote I want to read you. And the reason I'm pointing this out is this is by a man named Bob Martin. He's a very, very kind of well-known, prestigious guru of programming and programming principles. Let me read this. The principle of dependency inversion is at the root of many of the benefits claimed for object-oriented technology. Its proper application is necessary for the creation of reusable frameworks. It is also critically important for the construction of code that is resilient to change. And since the abstractions and details are all isolated from each other, the code is much easier to maintain. So, the point of this quote is to explain essentially that the claims of object-oriented programming, that you can separate your classes apart and they will all operate independently and they will all black box themselves, is intimately connected to the idea of dependency inversion. The fact that you are writing classes means that you have started down the road to understanding object-oriented programming. But if you are not somehow providing this dependency inversion, then you're missing the key point. And singletons are expressly not satisfying this particular need. And it is a crucial need. And if you've ever built a large project and found as you've gone further and further in that the code has become less and less maintainable, that you've created spider webs of dependencies, you felt that somehow, although you know all the design patterns, you're missing a piece. There's something that hasn't been working. It's probably this. It's probably that you have simply never been instructed or never discovered that the key way that you can keep your code, all these classes separated, is through inversion, through having some third party that instructs the individual classes what the concrete classes are that satisfy their dependencies. All right? So what's our solution? Our solution is called StrangeIoC, the IOC for inversion of control. Strange was built for Unity 3D and C#. So there are other inversion of control systems that exist for Unity. I think most of them are actually newer than Strange. Strange is free, it's open source, and it is built on top of, or not, it is built on the principles founded by another inversion of control framework called Robot Legs. It comes out of the Flash world, and that's where my history is. And so I learned about inversion of control through Robot Legs and Swift suspenders, and when we got to Unity and realized that there really wasn't anything comparable, we built it and open sourced it for you. So just to give you a sense of what Strange is, the dependency injection, the inversion of control, is a part of Strange. It's a really important part, but it's not quite the whole story. In addition to dependency injection, we provide different ways of doing injection. I don't want to go into the details here too much. Various things you can do around your construction. We provide an MVCS structure. Now, MVC you're probably familiar with, Model View Controller. S adds the notion of services, and a service is anything outside your application. So the model is governing your state. The view is everything that you see and hear. The controller is the instructions, the sort of glue for your application, the things that happen. And the S is everything that goes outside, so web services, or indeed down to the, if you're a mobile app, maybe down to the native layer. We also have publication subscription systems that allow you to communicate anywhere around your app, making your app very flexible because the communications are all handled for you. It's actually a much better communication system than, say, the broadcast message system, and it actually allows you some options as to how you use it. View mediation is a somewhat more complicated topic, but it basically has to do with separating out the code that governs your views from the rest of your app in order to keep things clean. and multiple binding contexts. So I was sort of showing you contexts earlier. It's where you create your bindings. And having multiple contexts gives you the ability to break a large application into lots of small, you can think of them as scenes, right? Each scene can be a context. You can actually have multiple scenes that are within a context. There's lots of ways to construct that. But the advantage is that you can build parts of your app, parts of your game in small components, and they will run on their own, and they can be tested on their own. And then when you're ready, you can bring them all together into a single larger app. And what's lovely about that is that then, especially on a bigger team, people can step away and do their own work and then come back together again at the end, and everything will fit into place. So taken together with the inversion of control, the dependency injection, the publication system, pub subsystems, the context, this whole thing basically amounts to what we call an Uber pattern. It handles what used to be for you, your singleton pattern and your factory pattern and a slew and observer patterns and a whole slew of design patterns that you may have used to architect your app. Strange is taking all of this and putting it together so that you can get on with the business of building your app and spending a lot less time thinking about how to structure it. All right? So that takes care of the first half of my talk, which I'm going to stop this here. The second half of the talk, we'll get into some actual code so you can see exactly what I've been talking about and how this whole dependency injection principle is going to work. All right, thank you very much.